Designing a paint hangar requires adherence to a complex web of international regulations and standards to ensure safety and operational efficiency. Effective research in this area involves exploring various codes, standards, and guidelines from different organizations and countries. The NFPA, or National Fire Protection Association, is a significant resource. NFPA standards provide comprehensive guidance on fire protection and safety aspects relevant to paint hangars. Specifically, NFPA 33, titled Standard for Spray Application Using Flammable or Combustible Materials, is highly relevant. This standard covers requirements for ventilation, fire suppression systems, electrical systems, and other safety measures to minimize fire and explosion hazards in spray application areas. The MHDBK-xxxx mention suggests familiarity with military handbook specifications, and depending on the specific numeric designation, this could be pertinent. Military handbooks often contain detailed requirements for aircraft painting facilities, including hangars. It's essential to identify the exact MHDBK document number to determine its specific relevance. Beyond these sources, it's crucial to investigate international standards and regulations. The International Building Code, or IBC, provides a model code that many countries and regions adopt or adapt. The IBC addresses various aspects of building design and construction, including fire safety, structural integrity, and occupancy requirements. Chapter 4 of the IBC, Special Detailed Requirements Based on Occupancy and Use, is especially relevant as it covers specific requirements for various types of occupancies, including aircraft hangars. European standards, specifically those published by the European Committee for Standardization, or CIN, are also important. EN standards cover a wide range of topics, including fire safety, ventilation, and electrical safety. EN 1539, dryers and ovens, in which flammable substances are released to circumflex safety requirements, might be applicable, especially if the paint hangar involves drying or curing processes. Furthermore, exploring regulations from specific countries where the paint hangar will be located is vital. Each country may have its own building codes, fire codes, and environmental regulations that must be followed. Contacting local authorities and regulatory agencies is recommended to obtain the most up-to-date and accurate information. To conduct an effective search, firstly, define the scope of the paint hangar project, including its size, intended use, and location. This will help narrow down the relevant regulations and standards. Secondly, create a comprehensive list of keywords related to paint hangars, such as aircraft painting, spray booth, fire suppression, ventilation, hazardous materials, and explosion protection. Thirdly, utilize online search engines such as Google, Bing, and specialized engineering databases to search for relevant documents and information. Use a combination of keywords and phrases to refine search results. Fourthly, consult industry-specific organizations and associations such as the Aerospace Industries Association, or AIR, and the National Air Transportation Association, or NATA. These organizations often provide guidance and resources on paint hangar design and safety. Fifthly, review technical journals, conference proceedings, and publications related to aerospace engineering, fire protection, and industrial safety. These sources may contain valuable insights and best practices for paint hangar design. Sixthly, consider engaging with consultants and experts in paint hangar design and safety. They can provide specialized knowledge and guidance on navigating the complex regulatory landscape. When reviewing regulations and standards, pay close attention to the following key areas. Firstly, fire protection. Ensure that the paint hangar is equipped with adequate fire suppression systems such as sprinklers, foam systems, and fire extinguishers. The design should comply with fire resistance requirements for building materials and structural elements. Secondly, ventilation. Provide adequate ventilation to remove flammable vapors and maintain safe air quality. The ventilation system should be designed to prevent the accumulation of explosive mixtures. Thirdly, electrical safety. Ensure that all electrical equipment and wiring are installed and maintained in accordance with electrical codes and standards. Use explosion-proof equipment in areas where flammable vapors may be present. Fourthly, hazardous materials. Implement proper storage, handling, and disposal procedures for paints, solvents, and other hazardous materials. Comply with environmental regulations related to air emissions and waste disposal. Fifthly, explosion protection. Implement measures to prevent explosions, such as grounding and bonding of equipment, using non-sparking tools, and installing explosion vents. Sixthly, personal protective equipment. Require employees to wear appropriate personal protective equipment, or PPE, such as respirators, gloves, and eye protection when working with paints and solvents. Seventhly, training. Provide comprehensive training to employees on the safe operation of the paint hangar, including fire safety procedures, hazardous materials handling, and emergency response protocols. Furthermore, consider the following design aspects. Firstly, hangar size and layout. Ensure that the hangar is large enough to accommodate the aircraft being painted and that the layout allows for safe and efficient operations. Secondly, lighting. Provide adequate lighting to ensure good visibility and prevent accidents. Thirdly, flooring. Use a non-slip, chemical-resistant flooring material that is easy to clean. Fourthly, drainage. Provide adequate drainage to collect spills and prevent the accumulation of liquids. Fifthly, access and egress. Ensure that there are clear and unobstructed access and egress routes in case of an emergency. Sixthly, environmental control. Consider implementing environmental control measures, such as temperature and humidity control, to optimize paint application and drying processes. In addition to the above, it is also crucial to consider environmental regulations related to air emissions and waste disposal. Paint hangars can generate significant air emissions, including volatile organic compounds, or VOCs, and hazardous air pollutants, or HAPs. Comply with all applicable air emission regulations, such as those issued by the Environmental Protection Agency, or EPA, in the United States, or similar agencies in other countries. Implement control technologies, such as carbon adsorption systems and thermal oxidizers, to reduce air emissions. Also, properly manage and dispose of paint waste, solvents, and other hazardous materials in accordance with environmental regulations. This may involve using licensed waste disposal companies and following specific procedures for labeling, storage, and transportation. Staying current with the latest regulations and standards is essential, as they are subject to change. Subscribe to updates from regulatory agencies and industry organizations. Attend conferences and workshops to learn about new developments in paint hangar design and safety. Regularly review and update the paint hangar's safety procedures and training programs to ensure compliance with the latest requirements. Addressing specific technical aspects in the paint hangar's electrical system, it's imperative to adhere to stringent safety standards to mitigate fire and explosion risks, especially given the presence of flammable vapors. The National Electrical Code, or NEC, Article 500 through 505, addresses hazardous locations. These locations are classified based on the type and likelihood of flammable substances being present. Paint hangars typically fall under Class A locations, which involve flammable gases or vapors. Class I locations are further divided into divisions, with Division 1 indicating that ignitable concentrations of flammable gases or vapors are likely to exist under normal operating conditions, and Division 2 indicating that such concentrations are likely to exist only under abnormal conditions. Within Class I locations, groups are also defined based on the specific flammable substance. For instance, Group D includes common solvents like acetone, alcohol, and toluene. Electrical equipment installed in these hazardous locations must be specifically designed and certified for the appropriate class, division, and group to prevent ignition. Equipment certified for hazardous locations includes explosion-proof enclosures, intrinsically safe circuits, and purged and pressurized systems. Explosion-proof enclosures are designed to contain an internal explosion and prevent it from propagating to the surrounding atmosphere. Intrinsically safe circuits limit the energy available in electrical circuits to a level that isn't sufficient to ignite flammable vapors. Purged and pressurized systems maintain a positive pressure of clean air or inert gas within an enclosure to prevent flammable vapors from entering. When designing the electrical system, firstly, use explosion-proof lighting fixtures that are rated for the specific hazardous location. These fixtures are designed to contain any internal explosion and prevent it from igniting surrounding flammable vapors. Secondly, install all electrical wiring in rigid metal conduit or other approved wiring methods that provide mechanical protection and prevent the escape of sparks or flames. Thirdly, use explosion-proof junction boxes and fittings to enclose electrical connections and prevent the escape of sparks or flames. Fourthly, ground all electrical equipment to prevent the buildup of static electricity, which can be a source of ignition. Fifthly, install emergency shutdown switches at strategic locations throughout the paint hangar to quickly de-energize electrical equipment in the event of a fire or explosion. Sixthly, regularly inspect and maintain electrical equipment to ensure that it is in good working order and that all safety features are functioning properly. Regarding ventilation systems, proper design and operation are critical for maintaining safe air quality and preventing the accumulation of flammable vapors. Ventilation systems should be designed to provide adequate air changes per hour to remove vapors and keep their concentration below the lower explosive limit, or LEL. The LEL is the lowest concentration of a flammable substance in air that will ignite. The American Conference of Governmental Industrial Hygienists, ORCJ, publishes threshold limit values, or TLVs, for various chemicals, including solvents used in paints. These TLV represent the concentration of a substance in the air to which most workers can be exposed without adverse health effects. Ventilation systems should be designed to maintain solvent concentrations below both the LEL and the TLV. There are two main types of ventilation systems. Firstly, dilution ventilation, which involves supplying fresh air to dilute the concentration of contaminants in the air. Secondly, local exhaust ventilation, which involves capturing contaminants at their source before they can be dispersed into the air. Local exhaust ventilation is generally more effective than dilution ventilation, especially for controlling hazardous substances. Paint hangars typically use a combination of both types of ventilation. When designing the ventilation system, firstly calculate the required airflow rate based on the volume of the paint hangar, the rate of solvent evaporation, and the desired air change rate. Secondly, select appropriate fans and ductwork to provide the required airflow. The fan should be explosion-proof and the ductwork should be made of non-combustible materials. Thirdly, locate exhaust inlets near the source of solvent vapors, such as spray booths and mixing areas. Fourthly, ensure that the exhaust system discharges to a safe location away from occupied areas and air intakes. Fifthly, install air monitoring equipment to continuously measure the concentration of solvent vapors in the air. This equipment can be used to automatically adjust the ventilation rate as needed. Sixthly, regularly inspect and maintain the ventilation system to ensure that it is operating properly. This includes cleaning ducts, replacing filters, and checking fan performance. For fire suppression systems, paint hangars require robust fire suppression systems to quickly extinguish fires and minimize damage. The type of fire suppression system used will depend on the specific hazards present in the paint hangar. Common types of fire suppression systems include, firstly, sprinkler systems, which are effective for controlling fires involving ordinary combustible materials. Secondly, foam systems, which are effective for suppressing fires involving flammable liquids. Thirdly, carbon dioxide, or CO2 systems, which are effective for extinguishing fires in confined spaces. Fourthly, dry chemical systems, which are effective for suppressing fires involving flammable liquids and gases. Sprinkler systems are typically designed in accordance with NFPA 13, standard for the installation of sprinkler systems. Foam systems are typically designed in accordance with NFPA 11, standard for low, medium, and high expansion foam. CO2 systems are typically designed in accordance with NFPA 12, standard on carbon dioxide extinguishing systems. Dry chemical systems are typically designed in accordance with NFPA 17, standard for dry chemical extinguishing systems. When designing the fire suppression system, firstly, determine the fire hazards present in the paint hangar, including the types and quantities of flammable materials. Secondly, select the appropriate type of fire suppression system based on the fire hazards. Thirdly, design the system to provide adequate coverage and discharge rates to quickly extinguish a fire. Fourthly, install the system in accordance with applicable codes and standards. Fifthly, regularly inspect and maintain the system to ensure that it is in good working order. This includes testing the system, inspecting sprinkler heads, and recharging extinguishers. Moreover, it is important to ensure that all personnel working in the paint hangar are properly trained in fire safety procedures and the use of fire suppression equipment. Conduct regular fire drills to practice emergency response procedures. Post emergency contact information and evacuation plans in prominent locations. Addressing hazardous material handling, strict procedures are essential for handling paints, solvents, and other hazardous materials to prevent spills, leaks, and exposure. Firstly, store hazardous materials in approved containers that are properly labeled and sealed. Secondly, store flammable liquids in a well-ventilated area away from ignition sources. Thirdly, provide spill containment measures, such as dikes or berms, around storage areas to prevent spills from spreading. Fourthly, use appropriate personal protective equipment, or PPE, such as gloves, respirators, and eye protection, when handling hazardous materials. Fifthly, follow safe work practices, such as avoiding open flames, sparks, and smoking in areas where hazardous materials are present. Sixthly, have spill response procedures in place to quickly contain and clean up spills. Seventhly, properly dispose of hazardous waste in accordance with environmental regulations. Also, comply with Occupational Safety and Health Administration, or OSHA, regulations regarding hazardous materials handling. OSHA provides specific requirements for hazard communication, personal protective equipment, and emergency response. To comply with environmental regulations, paint hangars must implement measures to control air emissions, manage waste, and prevent water pollution. Firstly, use paints and solvents with low volatile organic compound, or VOC, content to minimize air emissions. Secondly, install air pollution control equipment, such as carbon adsorption systems and thermal oxidizers, to reduce air emissions. Thirdly, properly manage and dispose of paint waste, solvents, and other hazardous materials in accordance with environmental regulations. Fourthly, prevent spills and leaks from contaminating soil and water. Fifthly, obtain all necessary permits and licenses from environmental regulatory agencies. Furthermore, comply with EPA regulations regarding air emissions, waste management, and water pollution. The EPA provides specific requirements for reporting, monitoring, and record keeping. Finally, regular inspections and maintenance are essential for ensuring the safe and efficient operation of paint hangars. Conduct regular inspections of all equipment and systems, including electrical systems, ventilation systems, fire suppression systems, and hazardous material storage areas. Perform preventive maintenance on equipment to prevent breakdowns and ensure optimal performance. Keep detailed records of inspections, maintenance, and repairs. Address any deficiencies or safety hazards promptly.